In this video, we are going to look at the mechanisms of halogenation of alkanes. As we said in the previous video, alkanes are basically unreactive because of their saturated nature. But we have other mechanisms or other ways by which we can make them reactive. Alkanes are basically made to be reactive when they are converted to a radical. So if you have a methane and you heat the methane, you tend to produce a radical. That is, you tend to eliminate one of the hydrogens from this one, leaving a vacancy shell around the carbon. That is a radical. So we add this one to a chlorine gas without any condition. There's going to be little or no reaction. But when you heat these two compounds together, you're going to replace one of the hydrogens here with the chlorine, the hydrogen. And this reaction is called the halogenations of alkanes. Halogenation, we add halogens to alkanes. It involves series of reactions. So basically, if you have this and you add chlorine gas in heat, you're going to produce methyl chloride, then HCl, methyl chloride and HCl. If the reaction continues repeatedly, you can get several products by which these hydrogens will be replaced by the chlorine. Now let's go into the mechanisms involved in this reaction. If you heat these two compounds together, the first step of this reaction is called the initiation step. The initiation step. The initiation step is achieved by heating of the chlorine gas. When you heat the chlorine gas, you tend to split the two chlorines involved to two different radicals. So one chlorine and this chlorine. Each of these is reactive and is called a radical. This is a radical and this is a radical. The first step, which involves the splitting of the chlorines involved, is what we call the initiation step. So the first step for the halogenation of alkanes is called initiation step. And it is achieved by the heating of the chlorine and splitting them into radicals. Next, each of these radicals, one of the radicals will come and take one of the hydrogens in the methane. So we have two radicals here. One of them will come and abstract one hydrogen from the methane. So when it's abstracted, it will form an HCl with the hydrogen. Then you have a radical of the methane. So here it has 4 bonds. So when one hydrogen goes, we tend to have 3 hydrogens, leaving a vacancy. And this is a radical. So one of the chlorine has been used up. Next, this step, the second step, which involves the abstraction of the hydrogen by the radical chlorine, is called the propagation step. So this one tends to propagate one of the hydrogen from the methane, leaving the methane in its radical state. Next, we have one radical here, another radical here. Bear in mind here, one of the radicals was used to abstract this one to form the HCl. So the remaining radical here and this radical will interact in the last step to form a methyl chloride. And this step is called termination step. Termination. Termination step. So the reaction of the two radicals, the chlorine and the methane, in their radical state to form the alkyl halide or the methyl chloride, is called a termination step. So basically you have 3 steps involved in the mechanism of halogenations of alkanes. The first one is the initiation step, whereby the heat which is applied split this one can be heat or sometimes even sunlight. The heat applied will split the chlorines into 2 and leave them in their radical state. The next step is one of the radicals will come and abstract one of the hydrogens of the methane to leave the methane in its radical state and uses the hydrogen to form an HCl. That is propagation step. The final step is these 2 radicals left will now interact to produce a methyl halide. That is an alkyl halide. So when you hydrogenate an alkene in the presence of heat, you finally get an eka halide. So these are the steps involved in the mechanism of halogenation of alkenes: initiation step, propagation step, and termination step. Thanks for watching.